Hi, this is our first video in Algebra 2 on greatest common factors and how to take an expression and pull out a factor from that expression. Now, what do I mean by pull out an expression? And what do I mean by factoring? Basically, what you have is a situation where if you have an expression, a big long expression, you'd like to come up with another expression that is basically a multiplication of two or more things. Those things are factors. Now, you're going to say, well, geez, what the heck, what does that mean? As we progress through these problems, you'll understand exactly what I'm talking about. But let's talk about what a greatest common factor is. Now, I'm going to go through, scan through the homework that you'll be presented. You're going to get different questions than I get, so I don't really have that much of a problem doing the homework in front of you. But the homework starts off with a bunch of variables in the very beginning. Let me just start off with some numbers and figure out what greatest common factor deals with in terms of numbers. Now, if I give you two numbers here, this is my little scratch pad. If I have two numbers, click this, okay, 36 and 48. Okay, 36 and 48. What the greatest common factor is give me the biggest number that divides evenly into 36 and 48. Can you think of what that number is? Okay, I'll let you think about it a little bit. I want the biggest number that divides into 36 and 48 evenly. Well, if you give it some thought, the answer is going to be 12. 12 is the answer. GCD is equal to 12. Now, that's the biggest number that divides evenly into 36 and 48. A lot of people say 2. 2 is a factor. It's not the biggest factor. Okay? So that's what the idea, but that's the idea behind the word greatest. You want the biggest factor that divides into those numbers. Now, if you couldn't tell it's 12, there's a little technique that you could use to get that answer. Somewhere in your math experience that you must have went over this thing called prime factorization. And what that means is you could take any number and break those numbers down into prime factors. Numbers that are primes are numbers that can't be divided other than by themselves or the number 1. So basically with prime factorization, what you do is, let's take the number 36. Break that down into, just give me two numbers that multiply to be 36. I think 6 and 6 would do the job. 6 and 6 would do the job here. Let's take a look at the 6. Can you break that down? I think you can. That's going to be 2 and 3. 2 and 3. And ditto on this 6. 2 and 3 here. 2 and 3. So I got, basically what that says is 2 and 3s are prime numbers. You can't break those down anymore. So what you're going to do is you're going to go along this, they call this a tree, upside down tree. You go through and go all the down the tree, and you say, well, how many 2's do we got? I've got 2 2's. We'll do it with exponents. 2 2's and 3. How many 3's do we got? Well, we have 2 3's right there. So that's the prime factorization with the exponents. 2 squared and 3 squared. Now, let's do the same thing with the 48. 48, 6 times 8. Doesn't matter. Just give me two numbers that multiply together to give you 48. Okay, 6 and 8. I could have said 4 and 12. You'll basically get the same answer. It doesn't matter. 6 and 8, I guess I can break down the 6 again to be 2 and 3. And those numbers can't be broken down. The 8, I can say, is 4 and 2. And of these numbers, 4 I can break down to be 2 and 2. 2 and 2. So the way I would express the number is I have 1, 2, 3, 4 2's. 2 to the 4th times, how many 3's do we got? Just 1 3. I could have put 3 to the 1, but it's just not cool to write down 1. It's assumed that the exponent's in 1. So this is the prime breakdown for this. That's a 4 now. What you would do to get this answer 12 is you say, well, GCD is equal to, now, I look at the prime breakdowns. Do you see 2's everywhere in both breakdowns? You absolutely do. So I see 2 is common. Okay, 2 is common. So what you do is you take the smallest exponent that you see. Well, I see a 2 and I see a 4. The smallest exponent would be 2. Is 3 common? It certainly is. If it's common, I list it. And what's the smallest exponent you see? Well, I don't see an exponent that's assumed 1. 1, the smallest exponent is 1. Don't write it down. And so what this is going to be, the exponents is 4 times 3 is your 12. Okay, so we found the greatest, we came up with a way to grab the greatest common divisor from numbers. And basically what's true with numbers is going to be true with exponents, with expressions with variables, like the problem number 1. Let me just go back to this one here. Let's pretend that we broke down our numbers, and let's pretend that we had the number 7 here as a breakdown. So pretend we broke up 48. It's certainly not this answer. I'm just pretending. Pretend I broke it down to get 2 to the 4th, 3 times 7. Now, the thing is, what you're going to do is you're going to scan your exponents, and you're always looking for common factors. 7 is not common, so I would not even attempt to list the 7 in the end answer, because 7 is not present there. So understand that. All the numbers that you list in the greatest common divisor, greatest common factor, are going to be numbers that are common. If it's not common, don't list it. And you always take the smallest exponent. Okay, let's start off nice and fresh. We'll do problem number 1 here. File. Let's close this out. Don't save it. We're going to say File, New. Start off with another nice fresh expression here. Now, this guy right here, I don't even think I need paper for this. We have 1, 2, 3 different expressions. We want the greatest common factor. Well, these are already broken down. You don't have to do the thing that we just did in the previous problem. These are already broken down. You have 3 expressions. This has got 5 y's, 7 y's, and this has got 4 y's. Well, I can tell you what the answer is going to be. Same thing with the numbers are y's common? They certainly are. I see y's everywhere. And so the factor is y, not the power. The factor is y, and y is common to those 3 expressions. You always take the smallest power that you see. I see the smallest power is 4. Let's see if that's right. Fantastic. Well done. We got 1 problem right. Great. Let's try the next one. Well, this is a little bit harder here. And so this might require a little bit of paper. Okay, so let's go over here. Negative 30, a to the 4th, b. And this, I'll put it on the side here, 5, a to the 5th. Now, when you find greatest common factor, negatives don't mean a thing. That's just a distraction. Don't worry about the negatives. Okay, what I would do is take a look at the numbers. These are all factors. Anything involved in a multiplication is a factor. Take a look at the numbers, disregard the negative. 30 and 5. Can you come up with the smallest number that, the biggest number that divides into 30 and 5 evenly? And I think you could. This doesn't require any breakdowns. Okay? The biggest number that goes into 5 and 30 evenly is the number 5. 5 divides into 5. 5 divides into 30 evenly. Now, some people may have said 10. Okay, now 10 does not divide into 5 evenly. That's important. Okay, the greatest common factor has to divide evenly into these numbers. So be careful of that. So the greatest common factor is 5. Now, do we see any other factors? I do. I see a factor A. A is a factor. Is it common to both? Yes, it is. A. So I list it, and you take the smallest exponent you see. Smallest exponent is 4. Okay, that's so far so good. I see another factor B. Is B common? I don't see a B over here, so don't list it. Don't list it. There's your answer right there. So I'm going to see if that's right. Let's move this over to the side. I'm going to type in 5a to the 4th power. Check my answer, and that should be good to go. Now, a little word about entering expressions. Make sure you enter the case of the letter properly. What that means is lowercase and uppercase might be different. Sometimes it takes it, sometimes it doesn't. Don't type it. Just if you see a small a, enter a small a. Don't put capital A. You're going to get that wrong sometimes. So why get it wrong when just type in the small a where it always works? So make sure that you understand that, because you don't need any more aggravation in your life. Okay? Don't put a capital A because it's not there's no capital A there. All right. Let's try the next one. Come on. Next one right over here. How about this one? Take a look at this one. I think I could sneak that up here. Okay, I see a negative 30, x to the 4th, y to the 4th, and then I got a 15, x cubed, y to the 4th, and this I may have to move over a little bit over here, and this is 60, x to the 4th, y cubed. Now these are all factors. These are factors. You see, anything involved in a multiplication is a factor. So I put little dots in there. Not that you need those dots. I just wanted to show you that everything is multiplied. So the first thing I would do is look at the numbers. What's the biggest number that goes into 30, 15, and 60? Well, I think 5 is the biggest number. The biggest number that divides into there evenly. Do you see another factor? I go left to right order. I see an x. That's a factor. Do you see it everywhere? If you see it everywhere, it's common. So I would put that there. And what you do is use the smallest exponent you see. The smallest exponent you see is a 3, x cubed. That's the smallest exponent I see. So we took care of the x's. And then the next thing that you're going to do is say, well, I see a y. Is y common? It certainly is. It's common, so you list it, and the smallest exponent you see is the 3. There you go. There's your answer. That's all you got to do. Now, let me just say, for instance, pretend there was no y over here. Let me erase that. Let me erase this over here. I'm going to go through my little, where's my little, I'm going to erase this. Pretend that was the problem with no y. Okay, pretend that was the problem, the original problem. Now, 5 would still work of the numbers. X is common, so I took care of the x. In this case, y has to be common to all 3 terms, and it's not. I would not include a y in my end answer for this problem over here. For this problem over here, the answer would be 5, for the problem that you see here, x cubed. No y's, because y has to be common everywhere. But for the original problem, that's what we have for an answer. Let me see if that's going to be right. 5x. You hit this little exponent cubed. Now make sure you bring the cursor down. Y cubed. Check your answer. Whoa, what did we do wrong? What did I do wrong? What did I do wrong? X to the 4th. X to the 4th, x cubed. 30, 15. This is y cubed. The original was y cubed. Did I hit the wrong button here? 5, x cubed, y cubed. Huh? That's right. That is absolutely right. That's the wonder of computers. I love computers. Let me stop the video and investigate. Oh, nope, they were correct. They were absolutely correct. I looked at this and they were correct. The issue is my greatest common factor on the number GCF is not 5. Not 5. I made a mistake. Oh no, don't get old. Here's the problem. 5 is a common factor. It's not the biggest. If you look at the number 30, 15, and 60, the biggest number that goes into 30, 15, and 60 is the number 15. 15, and in this made-up case, this would also be 15. That's the correct answer. I'm sorry about that. Sorry about that. Final check. Great. Excellent. There you go. Ah, well, so make sure, don't make mistakes. It's easier said than done. Let me clear out this thing. This file, close that out. And I don't want to save that. File, new, okay. Let's try this one. Now, what I'm going to show you here is something that you need to understand, and that's with parentheses. Parentheses indicate that this is one big bundle. Don't violate the bundle. The bundle is one big unit. It's a unit in itself. And so if I go and I express this as R bundle 5y minus 1 and 8, 5y minus 1. Okay. You do everything I say exactly in this problem as I did in the other problems. You look at all your factors. This is a factor, this is a factor, but the parentheses are taken as one big unit in itself. Don't go inside the parentheses and pull out the 5y or pull out the 1 or there. It's one unit. It's one unit in itself. So in terms of this problem here, the greatest common factor is equal to. Now, how did I do the other problems? I go in left to right order. Of the numbers that you see, I always use the numbers first. What's the number that's implied in front of the R? If you don't see a number, it's the number 1. Okay? And the greatest common factor of 1 and 8 is the number 1. And don't write down 1 unless you have to. Okay, so I'm not going to put down the 1. You have to is if you don't have any expressions. If this expression is blank, you have to put a 1 there. But for now, let's hope that we get some factor going here. Let's see, R. I see an R as another factor. Do you see an R term here? Nope, so don't list it. This one bundle is one unit. Do you see that same bundle over here? I do see it over there as well. So that unit and that unit are common, so I'm going to list that down like so. 5y minus 1. And the smallest exponent of that bundle that I see is the number 1. If you don't see an exponent, it's 1. And that's my expression right there, greatest common factor. So you come here and you write down this guy here, parentheses. Make sure you put the parentheses, 5y minus 1. Close the parentheses, check your answer. Excellent, excellent, excellent. Okay, now comes the actual factoring. Okay, this is where we start doing some serious factoring right now. Let's close this up. Don't save that. File, new, and we'll do this again here, and we say, well, 5y plus 105. Okay? The one thing that you need to understand in this course is pluses and minuses bind terms together as one unit. There's like an implied set of parentheses there. Pluses and minuses bind terms together as one unit. You may not have heard of that. I think this is the way you should. With this entire course involves 95% of this course is factoring. Okay, and so here we have two terms. Those terms are separated by plus and minus signs, but this is one big unit. Now what you want to do is factor that unit. So what we want to do is forget the plus sign. I just take a look at those two terms right here and ask yourself, what's the greatest common factor? The greatest common factor is going to be equal to, just look at the 5y and a 105. It looks like it might be 5. 5 is the biggest number that goes into 5 and 105. Again, don't worry about the plus sign. The plus sign separates the terms. I would not include a y because this 105 does not have a y, so don't include it. That's your greatest common factor right there. That's one factor. Now, to truly factor this entire expression, you need to say, well, okay, that's all well and good, but I need to reconstitute the original expression. So I need to come up with a set of parentheses, okay, that's big enough to hold two terms. I'll put the plus sign right in the middle. Just put the plus sign right in the middle. That separates the two answers that I'm going to try to get. Now, when you pull out a 5, what you're really doing is you're dividing these expressions by what you pull out. So 5 is what you pulled out. 5 goes into 5y. Well, 5 divides out. It leaves you with the plain y. When I pull out a 5 from 105, you're really dividing into the 105. So if I divide 105 by 5, I get 21. And guess what? That's the answer right there. You factored it. You took an expression and you broke it down into two parts, 5 and y plus 21 bundle. That's one unit right there. So you're going to take this and put this in there, 5 parentheses y plus 21, hit enter. Excellent, excellent, excellent. Okay. Now I know in Algebra 1 they gave you a problem like this. They gave you a problem like this, and they told you to distribute. Okay, distribute the 5 into the parentheses. That means you have to multiply every expression by 5 inside there to get this answer. See, now we're going backwards. See, we're getting with this one big expression here and breaking it down, sort of like a reverse distribution, going in backwards. So that's what Algebra 2 is all about, taking big expressions and breaking them down into smaller ones, a product of smaller ones. Okay, let's try the next one. Let me try something else. I'm going to skip this one. Let's try this one. Okay, let's try 28x squared plus 8x. And I want to break that expression down. See, this is one big expression because pluses and minuses bind terms together as one unit. And you need to break that unit down into smaller parts. I look at the 28, I look at the 8. Okay, I look at the 28, I look at the 8. Let's do it over here on the bottom. I think the biggest number that divides into 28 and 8 would be the number 4. That would be it. Do you see anything else that's common between those terms? X's. Pull out an X. The smallest exponent you see is the number 1, so don't worry about that. Don't put down 1. Just not done. Okay, so we found one factor right here, the greatest common factor. And what we're going to do is now make a set of parentheses big enough to hold two terms. And what I do is I just put down the plus to separate the terms, the left and right one. Now what goes here? If you pull out 4x, what you're doing is you're saying 4 goes into 28 7 times. See, think about what you would have done in Algebra 1. 4 times 7 will give you the original, the 28. You had two x's, you pulled one out, leaves you with the x. See, think about what you would have done in Algebra 1, multiplying through, you'll get this. 4 goes into 8 2 times. You pulled out the x. See, if I multiply this times 2, I'll get the original 8. That's the original answer. That's the answer right there. Fun, huh? We're having a great time. 4x. 7x plus 2. Okay, check your answer. Excellent, excellent. Almost halfway done, and we've survived. We've survived right now. Okay, let's try to separate this and separate this. And I'm going to do one that's a little bit bigger, I think. I'll do number 9. I'll do number 9. Because I think this is the first time we saw a minus sign. So let me do number 9. 5x squared y minus 10 xy squared. That's one big bundle. One big bundle. So what we want to do is break that bundle apart. I don't worry about the minus sign. I just look at the individual terms. I see 2 terms there. Let me push it up a little bit. I see 2 terms there. Okay, take a look at the 2 terms. Look at the numbers, 5 and 10. Looks like I can pull out a 5, the greatest common factor of 5. I see an x that's common. That's okay. That's great. X is common. The smallest exponent x you see is 1. Good. Y, I see a y factor. I see a y there too. That's common. And the smallest exponent I see is 1. That's it. Don't write down the 1. You came up with one factor right over here. Now make a set of parentheses big enough to hold 2 terms. Put a minus in between. And what you're doing is you're pulling out a 5x. That pulling out means you're dividing. 5 into 5 goes in once. I don't write down 1 unless I have to. What do I mean by have to? Well, let's continue the process. You had 2 x's, you pulled 1 x out, leaves you with an x. I don't need to put down a 1 because I already have an x there. Don't need to put 1x. It just doesn't look right. You had 1y, you pulled 1y out, you're done. That's it. Think about what you would have done in Algebra 1, multiplying through. Multiplying through, you would have got that first term. 5 goes into 10 2 times. Okay. X has been pulled out. No x's. You had 2 y's, you pulled 1 out, leaves you with a y, and there's your answer right there. Okay, there's your answer right there. So when I click this, I'm going to type in 5y, 5xy, parentheses, and what was that? X minus y, minus 2y. X minus 2y, close the parentheses, check your answer. Nice work. Nice work. All right, so this is almost like what we just did. Let's try another one. You know what? I'm going to go with the even bigger one. Let's go back. Number 11. Number 11. Let me clear out my palette here. Don't save. File, new. Okay. Come over here. I'm going to copy the problem. Always copy down the problem. Okay, now let's analyze this. Pluses and minuses bind terms together as one big unit. There's an implied set of parentheses there. You just don't put the parentheses here because it doesn't look right. It just doesn't look right because when you put a set of parentheses there, you're usually implying that you want to multiply that big unit by something else, but that unit isn't multiplying by something else. It's just there. Okay, so what we want to do is rip that unit apart into separate factors. Is it possible? Well, how many terms do we have here? Pluses and minuses separate the terms. So I got 1, 2, 3 terms. Okay, good. So take a look at the 3 terms. I really don't care about the plus and minuses. Don't care. I look at the numbers. I think 3. Greatest common factor, 3, 3, and 9. That's it. That's the answer. Now, what do? Can I pull out an x? No, can't pull out an x. There's no x on the 9. It's not common. That's the best you can do is 3. Make a set of parentheses big enough to hold 3 terms. Separate the terms with the pluses and the minuses in that order. And now if I pull out a 3, what you do is you're dividing each term by 3. 3 goes into 3 once. Don't write down the 1. I'm not pulling out any x's, so leave the x's the way that the x term's original. 3 goes into 3 once, leaves you with that 1x. 3 goes into 9 3 times, and there's your answer right there. I know it's the answer. I don't need the computer to tell me that's the answer, because in Algebra 1 you would have multiplied through, distribute, and you would have gotten the original answer. But if you're happy, you want to see this, okay, you want to make sure you want to see this. I might be lying to you. I did get one wrong already, so who knows? You can never trust anything. Can't trust anything here. No, I can't trust. Where did I put this? Oh, there it is. I don't know what happened there. Move this down. 3x to the 6th power. 6th power. Make sure you get that. Don't keep typing because it's in the exponent mode. You got to make sure you go down. Plus x minus 3. And check your answer. Well done. Fantastic. Oh, just almost done here. Almost done. Now, let's do this one. Number 12, I'm going to separate this. I'm going to say 6b to the 4th power minus 4b cubed. It's a b cubed, sorry. Plus b squared. So pretend, I can save that. I can save that. Here, I can take that little smudge out of there. There you go. That's a beautiful b. All right, let's analyze this. Well, I analyze this by saying that's a big set of parentheses. That's one big expression, one bundle, and inside that bundle there's 1, 2, 3 terms because pluses and minuses separate the terms. Okay. Let's find the common factor. 6, 4, and 1. There's a number 1 there. If there's no number, there's number 1. The greatest common factor is 1. Okay, so I don't write down 1 unless I have to. What about b's? I see a b here, a b here. Oh, I see b's everywhere, so I'm going to say the greatest common factor is b, and the smallest exponent I see is the 2. There it is. There it is. So now what you're going to do, you factor out the greatest common factor, make a set of parentheses big enough to hold the 3 terms, put a minus and a plus in between. I'm going to factor out a b squared, which is actually, the variables are actually easier. Okay, you start off with 4 b's, you pull 2 out, leaves you with 2 b's. Okay, we didn't do anything with the, oh, by the way, there's a 6 there. 6, 6, 6, 6, because we didn't do anything with the numbers. The numbers survive. The 4 survives. You had 3 b's, you pulled 2 out, leaves you with 1 b. You had 2 b's here, you pulled 2 b's out. Now, some people put 0. That would not be right. Don't put 0 there because b squared times 0 is 0. This is the case where you have to put the 1. Another way, or you lose the term. Because think about it. Multiply through. If I multiply through, I'll get the b to the 4th, the 6b to the 4th. I multiply through, I get minus 4b cubed. B squared times 1 is the b squared. So you make sure you have to put the 1 there. So let me make sure I move this over here. Let me see if I can move this here and say, well, here's my answer. B squared, and then we have 6b squared, exponent, you're going to use this a lot, minus 4b, I made a mistake, plus 1, close the parentheses, check your answer. Great, great, great. Great, great, great. Only a few more problems. Let me quick scan of what's next. Okay, I'm going to do 13 and then the mother of all problems, 15. And I think that should be, you're well on your way to doing the homework. Don't save that. Let's start off nice and fresh. New. Come over here. New sheet of paper. A virtual sheet of paper. I'm going to write down the problem 6x to the 7th minus 42 x to the 6th plus 30 x to the 5th. Okay, we wrote it down on our paper. Now we analyze what we wrote down. Yep, Professor Silvestri says that minuses and pluses bind these terms together as one big unit. So I'm going to put a set of parentheses around that. Now, the whole idea behind factoring is to take that unit and rip it apart into separate factors involved in multiplication. Well, okay. Take a look at these numbers. I don't care about the minuses and pluses. I'm just looking at this term, that term, and that term. 6, 42, and 30. I think the best you can do is pull out a 6 for sure. You can pull out a 6. That's the biggest number that goes into those numbers. How about an x? Is x common to all terms? All terms? Yeah, x is common. And the smallest exponent, x sub c, is 7, 6, 5. 5 right there. And then what you're going to do is make a... So that's one factor right over here. That's one factor. Make a set of parentheses big enough to hold 1, 2, 3 terms. Put the minus and the plus in between. And then you're going to say, well, all right, what do we do here? Just take each of these things are separate little problems. You look at this. You pull 6 from 6 leaves you with 1. I don't want to write down the 1 unless I have to. You had 7 x's. You pulled 5 out, leaves you with the square x squared. I don't need to put the 1. Look at this term. 6 goes into 42 7 times. You had 6 x's, you pulled 5 out, leaves you with 1x. 6 goes into 35 times. You had 5 x's, you pulled them out, good. I know that's right because if I go ahead and multiply through like you did in Algebra 1, you would have got the original problem. So let's see if that's correct. 6x to the 5th power. Parentheses, x squared minus 7x plus 5, close the parentheses, check your answer, fantastic. There you go. And the mother of all problems, usually the last one is the hardest one. Oh my God, look at that mess. Let's come over here. Separate, 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 separate that. Ooh, it's hard to write. 15. M cubed n plus 25 m n cubed. So basically m and n plus 65 m to the 4th n squared. Okay. That's one big bundle. That's one big bundle because pluses and minuses bind terms together into one unit. One indivisible atomic unit. Okay. This unit has 1, 2, 3 terms because the pluses and minuses separate terms. So take a look at those separate terms. Take a look at the numbers. What is the biggest number that goes into 15, 25, and 65? I think it's 5. 5 for sure. We'll see. We'll see what happens. Now, I scan left to right. I see an m here. The factor is m, not the m cubed. The factor is m. It just happens to occur 3 times. That's what that means. That's what that exponent means. Is m common? It certainly is. What's the smallest exponent m you see? 1. 1. So I don't write down a 1. Okay? Don't need to. It's implied. N. Do you see an n everywhere? Yes, I do. So it's common. The smallest exponent is 1. Don't write it down. Make a set of parentheses big enough to hold 3 terms, and you might as well copy the pluses to separate those terms, like so. Okay, what do we got here? When we pull out a 5, you're dividing. 5 goes into 15 3 times. You had 3 m's, you pulled 1 out, leaves you with m squared. You had 1 n, you pulled it out. I know that's the right answer for this term. Multiply through. Okay? That's how you check yourself. Multiply through, you'd get the original term. Now 5 goes into 25 5 times. You had 1 m, you pulled 1 out, no more m's. You had 3 n's, you pulled 1 out, leaves you with an n squared. Okay, so that term is done. I know that's right. 5 goes into 15 13 times. You pulled out from 4m, you had 4m's, you pulled one out, leaves you an m cubed. And you start off with n squared, you pulled one out, leaves you with an n. So there's your answer right there. Let's see if that's correct. Let's see. I hope it's correct. I don't want to get it wrong here because that's a pain. Okay, 5mn, 3m squared. Bring it down, plus 5n squared. Bring it down, plus 13 m cubed, bring it down, and close the parentheses. I'm going to check my answer. Nice work. And you can do some nice work too. So I hope I cleared up some problems here. Go do the homework. Don't put it off. Do it immediately. Get it done. And then next video we'll do sections 6-2. All right. Have fun. Bye.